Okay, are you seeing the screen?
Yes, sir.
Okay, so it's past paper. The first question says that an aeroplane of mass 2.5 times 10 raised to power kilogram land, means this is the mass of the aeroplane. Okay, lands with a speed,
Huh.
mean the speed is given, which is 62 meter per second on a horizontal runway at time t is equal to 0, mean there was initially time was 0. The, the aeroplane accelerates uniformly as it travels along the runway in a straight until it reaches a speed of 6 meters per second. A new speed is given. Initially, it has speed of 62, and finally, it has speed of 6 meters per second. And time is 3.5, sorry, 35 seconds. Calculate the deceleration of the aeroplane in 35 seconds after it lands. What mean deceleration? Here we have to calculate acceleration, negative acceleration. How you will calculate?
Acceleration is equal to final velocity minus initial velocity over time.
So what it will be?
So 66 minus 62,
6 minus 62 divided by what is time? Time is 35.
35.
So let me divide it. 1.65 meter per second square with a sign of negative. By the way, why negative sign?
But sir, negative is for negative acceleration. So deceleration, we just use the positive number.
Yeah, so we will write just 1.6 meter per second square. Is it okay?
Huh.
Next question says that the resultant force acting on the aeroplane as it decelerates. We have to calculate resultant force. Which formula we will use for resultant force?
F equals ma, Newton's
Very
second
good.
law.
Here we have calculated A and M for the aeroplane was given, which was in the question, which is 2.5 times 10 raised to the power 5 kg. So we will just
So
multiply it
do we use the negative acceleration?
about the direction. Here asking only about the magnitude. That's why we will use only positive sign. Okay.
Okay, sir.
Okay. So mass was 2.5 times 10 raised to the power 5 times acceleration was 1.6. So just multiply it and we will get the answer. Let me multiply it. It will come almost 400,000 newtons. Or you can write 4 times 10 raised to the power 5 newton.
Huh.
Okay. Next question. Next question says that in the momentum of the aeroplane plane when its speed is 6 meter per second. Here we have to calculate momentum. How you will calculate
Uh, by
momentum?
P equals mv.
Yes. So what is m in this case?
Our mass has already been given,
Very good.
2.5 times,
So
and
our
velocity.
yes given in the question which is 6. So just multiply 2.5 times 10 raised to the power 5 times 6 and we will get the answer. It will become 1500,000. 1500,000. So it will become 1.5 times 10 raised to the power 6 kilogram meter per second. Is it okay?
Yeah.
Okay, now move to the next question. Next question says that at time equal to 35 seconds, aeroplane stopped decelerating and moved along the runway at a constant speed of 6 meter per second for a further 15 seconds. Okay, on figure 1.1, sketch the shape of the graph for the distance traveled by the aeroplane along the runway between t is equal to 0 to t is equal to 50 seconds. You are not required to calculate the distance value. Here we have to draw the graph. So from the graph we can see that initially it takes 35 seconds to decelerate and after 35 seconds it moves with constant speed. So here the acceleration is decreasing, our acceleration is decreasing, it's decelerating, and
Uh,
after 35
Decreasing.
after 35 seconds we got its speed time graph, not its acceleration. If it is acceleration then we will have straight line, but it's not acceleration graph, it's speed time graph, sorry, distance time graph. So it will show velocity, and velocity is constant. That's why we here add it as straight line. Why straight line? Why straight line?
Because it's constant speed.
Yes, speed is constant. And by the way, this graph is for speed. That's why speed is constant. Okay. Next question says that as the aeroplane decelerates, its kinetic energy decreases. Suggest what happened to this energy. The aeroplane is decelerating, and he is asking what happened with this kinetic energy. So this kinetic energy appears as the thermal energy, and in some which which is used in brakes and air resistance and other things. Have you got the answer?
Huh.
Okay, next question. It is that in figure 2.1 is an extension load graph for a light spring S. Okay, so state the range of the
Huh.
load for which S is the spring obeys the Hooke's law. So Hooke's law says that
So
for, what is statement of Hooke's law or formula for Hooke's law?
it can only extend to like a maximum proportionality until shape and size is changed.
Yes, very good. So here the point where the graph is straight. So it starts from zero at this point and it ends at this point. So all the points between 0 to 8 shows a straight line. It means that it starts from zero Newton, and this proportionality ends at after 8 Newton. So that's why I have written from 0 to 8 Newton. Have you got the answer?
Huh.
Okay. Next question says that using the information in figure 2.1 determine the spring constant of the spring. So what is formula for spring constant or what is formula for Hooke's law?
F equals kx, so F equals constant time extension.
Very good. So how we will calculate here x? Can you, what is f here?
X, so initial is 0 and then until 8 it is
Yes, yes, it's 8 Newton. And by the way, what is mm, x?
X is extension.
Yes,
So
x
then
is extension which is related to this point. Let me this line. So it becomes almost 15. So here extension is 15 meter. Is it okay? Oh, sorry,
uh,
15 centimeter.
how? Yeah, yeah, yeah.
Have you got the thing?
Yeah, I get you, I get you, I get you.
So
Huh.
for our k, we will use k will be equal to f over x. So f in this case is 15 Newton.
8,
Sorry, 8 Newton. Sorry, not 15. It's 8 Newton.
8 over 15.
8 over 15. By the way, if we are calculating in meter, then we will use 0.15. Is it okay?
Huh.
It becomes 53.33. So you can write 53 Newton per meter. Is it okay?
Huh.
Why I have written in unit Newton per meter for this K?
Because newtons divided by meters. So force divided
Yes,
by extension. So
yes, very good. Okay. So next, not a second spring identical to spring gas mean here in the figure you can see there are two springs. So he is saying that a second spring identical to the spring as two springs are attached with a to a rod, okay, as shown in figure. A load of 4 Newton is suspended. Mean here load of 4 Newton mean force is given 4 Newton suspended from the bottom of the spring. Okay, the arrangement is in equilibrium as you can see. Okay, now first question says state the name of the energy stored in the two springs when they are stretched. So what is the name of the energy when the spring is stretched? What is energy in a stretched spring?
uh stretch spring is what energy? I think gravitational potential.
Why gravitational potential energy? Gravitational potential is about height, about position, but here we have stretch. So elastic potential energy.
Elastic.
Yes, yes,
Elastic.
yes. It will be elastic potential energy. Okay.
Ah.
Okay. Next question says that determine the extension of the arrangement in figure 2.2. So here we have to calculate the extension. By the way, for extension, we will again use formula of Hooke's law, which is formula F is equal to
F equals to
Kx.
kx.
So K is given, all we have calculated it earlier, which is 53, and F is given here, which is 4 Newton. So for X, we will just divide it F over K. So F over K. F is in this case, which is given, which is the load which is attached with this spring, 4 Newton divided by K. K is 53. Is it okay?
Huh?
So it is in meters, which is 0.0754 meter. But he is asking the question in centimeters. Then what will be in centimeters?
1 second, sir. I'm tired. Give me 1 minute.
Okay, okay, no issue. You can take.
Oh, we can continue.
Okay, I am saying that our question is 0.00754 meter. But he is asking a question in centimeters. Then what will be amount in centimeters?
From this that's meters. So then to get into centimeters, you times by 100.
Yes, it will be 7.5 centimeters. Is it okay?
Yes, sir.
Next question says that calculate the load is carefully increased to 6 Newton. Mean initially the load was 4 Newton. Now this 4 Newton has increased to 6 Newton. Okay. Now move to the question. Question says that calculate the distance moved by the load to the new equilibrium position as the load increases from 4 Newton to 6 Newton. So when initially we have a load of 4 Newton, then there was extension of 15 centimeters. Is it okay?
Huh.
Of 2 Newton, we will divide it by 2. So it will become 2 Newton is equal to will be equal to 15 divided by 2, and it will be equal to 7.5. Is it okay?
Huh.